Welcome everybody to today's session. My name is Vic Pant. I'm the host of the Synthetic Intelligence Forum, and it's my pleasure to welcome Dr. Xuedong Huang from Microsoft. He is a technical fellow at Microsoft, and he's also the Chief Technology Officer for Microsoft Azure Cognitive Services. Today, Dr. Huang will reflect on his decades of expertise in scholarship, in research, in academic pursuits, but also in practitioner and building AI systems that are getting us closer towards this holistic representation towards integrative AI. So without further ado, Dr. Huang, I'd like to invite you and welcome you to the stream. Thank you for joining us.
Okay, thank you. I would love to actually see in the future we can present the information sharing this in person. But well, with modern technology, we're able to do this virtually over the screen. Even though it's not as good, but well, that's a great progress to digitally transform what we can do together. So I'm very happy to be here today to share the journey, reflection, how Microsoft as a company through Azure Cognitive Services to deliver this amazing set of services and technology stack to advance integrative AI, to make it more like human, think like human, behave like human. So I just want to focus on the holistic representation layer. That is relatively low, but that will be foundational for the downstream task that they can be built on. So I want to start with the human's capability, really what it is that we are, it's just amazing what we can do as a human. And of course, we can see, hear, think, learn, and, we express ourselves through this amazing language. It's a phenomenon, our capability, we can communicate, we can organize, and, come together virtually today because we have this language capability and we can speak, hear, and see. Right, that is just, really the amazing human capability enabled us to really express ourselves, organize ourselves, and accumulate knowledge in a profound way that set us apart from the rest of the animals on the planet. So this capability is always the inspiration of the research on AI. So Microsoft, like many other great institutions, we have been pursuing this for the last 28 years, since the foundation of Microsoft Research. So when Microsoft Research was established, the focus was really make computer to speak, to see, to hear, to learn. That was actually really the AI. So when Microsoft Research was established, and the founding director, Rick Rashid, made a very simple analogy. He wanted Microsoft Research to work and research like Carnegie Mellon University Computer Science Department. So I want to highlight some of the recent achievement in the last 5 years, what we have done between speech, vision, and natural language. So as early as in 2016, Microsoft was the first to propose ResNet and achieved actually human parity on the research benchmark for object recognition. In 2017, on the most famous switchboard conversation task, that was the task for people to talk over the phone, and benchmark for almost 20 years in the speech research community. Once again, for the first time, Microsoft reached human parity in transcribing conversational speech for 2 people over the phone. Those are the research benchmark that got broadly used as indicator of the horsepower of the computer system. A year after that, our team also achieved human parity in translating Chinese news to English news. On the sentence-by-sentence basis, it was as good as professional translator. This was the WMT translation benchmark. Most recently, on the Facebook-sponsored novel object-based image captioning, we reached the human parity as recent as July. This is just really a high-level summary of the journey we have. And we push integrated AI in speech, vision, language, and for all of them, as we actually measure the progress on those research benchmark. We also really integrate that into Azure AI expressed through cognitive services. And that actually is available broadly worldwide and being broadly used by both Microsoft internal products, such as Teams, and also the third-party applications from Samsung to BBC. So it's really just amazing to see the research breakthrough started from Microsoft Research 28 years ago, where 29 years ago, probably, I joined Microsoft Research to fund the speech technology group. And I moved from research into Azure to lead cognitive services AI. And that's a just fantastic journey to see how we can really work together to push the envelope to make this integrative AI realistic and useful for the society. So before I start to share what we can do as a company, I want to really pause here to think about how we learn to read as a child. It's just fascinating, really, to see we are far more effective to actually use all the sensory, all the modality to accumulate and understand the real world. It's almost impossible for anyone, even as small as humans, to master a language by just simply sitting in the dark house, in a dark room, read the text. You can actually read, billions and billions of words, just like most of the recent language models. And in the end of the day, you cannot memorize as good as the bird-based transformer language model. But there's no way you can really understand the language. So when people learn, we use our vision, we hear the sound, we associate that with real word and concept, entity, etc. That's actually how people learn and understand language. I want to emphasize that language is really the most important indicator of AI's capability. As I said, on this planet, there are lots of animals. They can run faster than humans. They can see better than humans, even in the night, in the dark. And animals can smell better than humans, some of them. They can hear better, see better, but none of them can think better. None of them actually can express themselves better. So because of the language, we can really accumulate the knowledge, pass knowledge from one generation to another, and organize ourselves, create a country, create an institution, and enable all of us to come together on this forum to share our knowledge. So that is really the real reason why we are more intelligent and why we are the master of this planet. So for AI, it's going to be similar. So there was a lot of study. It had previously been thought and copiously published in the neuroscience community that there is pattern separation in the human brain that enable the memories to be stored by separate groups of neurons. Most recently, this British researcher just published to indicate that there's no pattern separation in the human brain. This is Professor Piroga had this published just a few months ago. It's fascinating to see that the shared representation is what set humans apart from the rest of the animals. So that's just fascinating to see the connection. And Microsoft has been pursuing this universal representation, what we call XYZ-code, for a long time. So it's pragmatic. Actually, we are thinking three most important attributes: text, sensory. Sensory includes both computer speech and computer vision. The reason we included this multilingual dimension is really pragmatic, because Microsoft is a global company. Any AI product, any language product we are offering, we want to actually support a broader set of languages. So that the capability to really localize a product to support hundreds of different languages is a business priority. And this is why we actually prioritize this multilingual as a one dimension in our pursuit of this universal representation. Pragmatically, it's also interesting to note, and most of the advancement of language processing is based on the masked language model. It's just unsupervised. We believe that one of the biggest barriers for language understanding progress is really the lack of supervised data. Just like the example I used, nobody can read the text alone to master the language. You need some label. The fact that the Rosetta Stone helped us to decode the ancient Egyptian language is a great example. And that multilingual corpora, parallel corpora, will give us a very powerful label to enable the language breakthrough. This is why Microsoft Cognitive Services always had the vision to get associative text, sensory, and multilingual as the three most important dimensions. And by jointly explore that intersection, we believe we can actually have a foundational representation that's more holistic, that can really drive the advancement of integrative AI. So I want to just actually reflect the journey. Let's talk about text. As early as in 2012, we have started this massive Xcode embedding internally. None of this was published, but the Xcode was really shipped to help our web search engine Bing to be more relevant. So the basic idea was very simple. When we process billions and billions of queries, we actually also have the user engagement signal. They click the document. So we have collected enough query document pairs. In that query document pair, I want to really take a notice of the scale we had. Really, we had billions query and the documents. We formed this massive model. And we maximize the mutual information between query and the document. Then through gradient descent, we can iterate, each query is a circle in this map. Each document is a star. Through multiple iterations, through massive embedding, we can organize the whole document and the query in a more cohesive way semantically. So we are able to really process this at a massive scale. But the lesson we learned was, because of the computation at that time, we didn't really go deep. We had a very, very broad model, but very shallow. So this was very interesting. It was very effective, used in the product. But the lesson was it wasn't deep enough. It was big, but it wasn't deep. So Google had this transformer-based BERT. Actually, Jacob used to be working in my team on machine translation. He left Microsoft, joined Google, and worked on this transformer-based language model, BERT. The transformer was actually super effective. That was initially used for translation. What the BERT is about is really to translate from masked text into the original text. So you can actually have the massive amount of data, build this encoding using the same transformer mechanism. So you can go much deeper than Microsoft Xcode. So 5 years after Xcode, this BERT really revolutionized the language processing community. It's just phenomenal. Dramatically improved how the natural language community is dealing with the language model as a foundational representation. So from Xcode to BERT is really a fantastic jump, because we have the transformer. We can go not only bigger, but we can also go deeper. So this is actually a very interesting dimension on the size. You can see starting from 2018, the size of the transformer-based deep learning model has been growing dramatically. Microsoft Turing is, one of such initiatives. More recently, we have GPT-3. That is actually another 10x bigger increase in the size. It's phenomenal. With a similar transformer-based architecture, by just focus on the size and the data, we can actually achieve something fantastic. It's amazing. So this is what the OpenAI GPT-3 team published. If you have, roughly about 1 billion parameters, your performance is actually around here. When you increase the performance by 10x, you can see the improvement. When you increase by another 10x, you have a huge jump on the capability. That enabled a really few-shot adaptation using this language model, even though it doesn't really understand the knowledge or concept, identity, etc. With this kind of large size language model, you can really provide a lot of realistic, great application as a representation. So that is really phenomenal along the X dimension. Starting with Microsoft Xcode to BERT to GPT-3, we have seen this dramatic improvement. So it has to be transformer based, has to be deep layered, and has to be big. That is really the X dimension. Now I want to talk about the sensory. This involves both pixel and the speech waveform and the Y code. So I want to start with this form understanding and OCR. This is very, very important business capability, because there are just lots of documents that require this capability to process, to automate, to digitally transform. Microsoft published this layout language model, and it's actually based on transformer, but we take advantage of both the text and the pixel. That is very important for the document image understanding. So through that, we can use a transformer. It's similar to BERT or translation, but we encoded both text and position information jointly. So that jointly encoded is what we call XY or Y code. By training text and the layout for document image understanding, we can dramatically improve the quality for form understanding with the layout language model. So on the, some of the examples we have here, you can see that the dramatic improvement in comparison to original BERT or Facebook's Roberta large language model for the task we're dealing with. The parameter is also not even actually, as big as the original text-based language model, but with position and text jointly trained, we pushed the performance to achieve the state of the art. So with that kind of representation, using layout and language model, we can have a wide range of downstream applications, such as receipt understanding and formal recognition. Once again, because of the layout and language model, because of the Y code and X code joint optimization, the performance is phenomenal. Really pushed the performance to the most accurate system we can have. So for the form and the OCR, I just give you that great example of joint training. Now I want to talk about the image caption. With Microsoft's recent achievement on the image captioning, we have really achieved something phenomenal. On that research benchmark, Microsoft Cognitive Services surpassed the human performance in Facebook-sponsored novel object captioning. So the key message is really, traditionally, if you perform the image captioning, you have the image, you have the caption as the training data, you jointly optimize on the image feature and the language feature. And with Microsoft approach, we introduced the Vivo. So just like, when you read or look at the image, you want to identify the basic entity first instead of memorizing the whole sentence. So we did break this whole sentence down into pieces, into the visual vocabulary level. Then we jointly train this image and language together. So that is very similar to how human approaches the same problem. When you teach your kid to read by, watching the image, the entity, the notion of accordion or apple, person, they are important. Instead of memorizing the whole sentence of the captioning, we need to really identify those key vocabulary in the pre-training. Then you can fine-tune to synthesize those sentences together. Even for the novel object in the image, because of that pre-training, because of breaking down of the sentence into the vocabulary that are essential, we can recombine them in a more intelligent way. That is actually how Microsoft system reached the human parity. More recently, with better image encoding, we could even further improve the performance we reported in July. So let's take some example how Microsoft, before the human parity breakthrough, performed the image captioning and the competition from the existing product out there. Probably that's the best competition system available in the market. And our latest result, that's just amazing. If you take a look at this picture, it was not wrong, a close-up of a ball. And our competitor also give the tennis ball. They're all accurate. But the new system really just did something phenomenal. It's a tennis ball on a racket. So that kind of detail entity really give us the very interesting captioning result. I want to share more result on the image captioning. Our old system is, is fine. But here is more descriptive. If you take another example, and it's a close-up of a planet, there's nothing wrong. Our competitor also said this is a planet. It's great. But here it's far more descriptive and accurate. And now you can see really why this human parity is a phenomenon. This capability is available on the iPhone app called Seeing AI. This is what Microsoft designed to help accessibility community for people with vision challenge. So you can actually install this app on iPhone and point this to anything, and captioning, the same service from Azure Cognitive Services is used for that app. In addition to that, the system can also speak up using the same Azure Cognitive Services capability like text-to-speech. So for a blind person, you can just point this to anything and hear what is going on in your environment. That's a part of our initiative on the AI for Good and AI for accessibility. So more example here. This is interesting. Our competitor made, thought this was a lamp or tripod. Our original Azure Cognitive Services thought it was a yellow sunset. Wasn't wrong, but it just missed the point. But here, the new result is really a satellite dish on dirty road. It's phenomenal to see how good this is becoming. Of course, even human can make mistake. So I want to just really point out, even with this research benchmark, reaching human parity is a major breakthrough. In practice, for the image in the wild, it can be still wrong. This is really a very interesting photo. This is the building of Beijing's Tsinghua University. Our older system thought it is a building on fire because of this red door, and under the light, it's almost like, like a fire is actually going on. And the new system didn't actually solve that problem. It's just more descriptive. It's with fire in the middle. It's a little bit descriptive, but they still miss the point. So even though we have reached the research benchmark breakthrough, but for the photo in the wild, all kinds of errors still happen. So that's the point I want to really make. It's a great progress. It's much better than the previous system, but it's never going to be perfect in practice. We still have a lot of work to do to further advance AI technology to better serve our customers. So I talked about X code, Y code on both sensory and the beyond the text optimization. I want to talk about the Z code. So we recently published this multitask learning for neural machine translation. Google also did something similar called G-Shot. And our approach is actually very ambitious. I don't think anyone is doing something similar. So for the neural translation through transfer learning, they put all the languages together. What we're doing is actually combining masked language model, very much like a bird, and the translation jointly together. So instead of just translate it yourself, mask some words into the original text, we do that. In addition to doing that, we also use the parallel corpora. So if you say you have English to French or German, that label is equally important. So we do the bird-like masked language model training using the same transformer encoder. We also have the parallel corpora of multiple languages that are typically used for machine translation. And we jointly optimize both masked language model and machine translation together to have a better encoding. That's what we call Z code. So the input data is both mono data and bilingual data. We actually use both information to jointly derive the representation that is born to be multilingual, that is more effective. So it can be used for both translation and the language understanding task. As the most aspirational push we have started with the Xcode journey we initiated in 2012. So from X to Z, that's a fantastic jump because we are able to really go bigger, but also go deeper using transformer. We not only actually have masked language model as objective function, we can also use machine translation data through that parallel label jointly optimize the representation. So the ending result is phenomenal. With Microsoft Z-code, you can see in comparison to the bilingual translation, we have actually achieved a substantial improvement in improving the quality across multiple languages for both high resource and the low resource. Those are the different languages on the row. On the column here, you can see this is, as if you just use translation from the bilingual data, build that neural translation model using transformer. And those are the low resource languages. But by putting all those data together, you can create one model. You can see the performance lift here and here. For the high resource language like French, we didn't actually have substantial improvement, but on the low resource language, we had sizable improvement for the translation. And this multitask learning also outperformed the auto pre-training method. So the orange is the multilingual bird, and the blue one is our Z-code. Here, you can see the improvement on the pre-training based performance. For the language understanding, this is for translation on the left. On the right, this is for language understanding. And for the English and other languages, Spanish, German, French, the blue one here on the right is the state of art Roberta. So you can see the Z-code actually further improved over the Roberta XLM. So we are also looking into using the same XYZ concept for the form and OCR recognition. Here you have the input, that's the document. You have the image, you have the visual content extraction. You can actually do that here. And you have OCR, that's multilingual trained. With multilingual XYZ-code, we can really have the layout classification that is very effective to deal with key value pairs, entity extraction, or question answering for the multilingual document. That is the research push we are very happy to see through this joint representation of the pixel language and the multilingual information, we can effectively produce this multilingual document understanding solution through Azure Cognitive Services. So on multilingual speech recognition is very similar. So the modern architecture is really, we put all the data together across all the languages. They are just the waveform. And then we jointly train the system to get the word out, the transcription. So we mixed all of them together, have the transcription of multilingual audio to multilingual text. So the traditional approach is really, if you want to actually deal with the multilingual speech recognition, you create your acoustic model and a language model. Let's say you have five languages. You have 5 systems, and you need a separate language identification. And with the new approach, we have one model. You can speak either English or French or German or Italian. And we'll just transcribe this naturally with like, similar performance. But what is amazing, instead of having, a system for each language, we can dramatically reduce the size with one model. We can actually do as well, a job in transcribing multilingual speech as the original system that's more traditional, but we can really dramatically save the size of model and the complexity. So This is the system that is super effective for the European Parliament, because they have representatives from 24 countries. In the debate of the European Parliament, they can really let you speak your native tongue and understood by everyone else, because we can simultaneously transcribe and translate. This was the scenario that we actually participated in the European Parliament international bidding. Started more than a year ago. 15 systems company, organization, or combo participated in that bidding. So the phase 1 ended. They had 15 different organizations submit the system to simultaneously transcribe and translate English, French, and German speech. And Microsoft Azure Cognitive Services turned out to be actually the best in every category, whether it's French or German or English, in live translating and transcribing the speech. So let me actually share with you the video of Microsoft system here.
Frau Präsidentin, liebe Kollegen, liebe Kolleginnen, ich möchte meinen ganz herzlichen Dank an die Berichterstatterin Katrin Styler aussprechen, die in diesem hochtechnischen Bereich eine sehr wichtige Arbeit gemacht hat. Denn es ist nicht nur ein technischer Bericht, es ist auch ein hochpolitischer Bericht, den wir vor uns liegen haben, in dem hohe politische Standards auch respektiert werden mussten. Es ging darum, die Belange der Wirtschaft, der Sicherheit, des Arbeitsschutzes miteinander in Einklang zu bringen. Und es ist ihr aus Sicht des Europäischen Parlaments und der Sozialdemokraten und Sozialdemokratinnen hervorragend gelungen.
Thank you, President. Well, some colleagues took the initiative of putting in the agenda an urgency resolution on Brazil's refusal to extradite Cesare Battisti to Italy. I do understand their motives, but as I shall demonstrate, this is not a present human rights case. It is not an urgent case, and it is not even a breach of the rule of law case. Furthermore, it comes at a terrible moment when Brazil is facing the worst natural disaster in its history. Cesare Battisti is in prison, is waiting for a decision of the Brazil Supreme Court.
Merci, Monsieur le Président. Je siège dans cet hémicycle depuis 1999 et en 20 ans, on ne peut pas dire que le cadre européen sur les perturbateurs endocriniens ait évolué. Quand la science, elle a changé. Des chercheurs ont révélé leur impact sur la santé humaine, sur la santé animale, le lien avec certaines maladies chroniques, en particulier certains cancers, l'infertilité, certains troubles du développement neurologique. Ce lien est avéré. L'Union européenne ne semble pas avoir pris la mesure de ce que l'OMS qualifiait en 2013 déjà de menace mondiale. Nous sommes très en retard.
So that is the demo. It's European Parliament finished the first round of evaluation for all the international company. Microsoft really offered the highest quality. We're very proud of that. So they entered the phase 2. They selected 3 institutions, including Microsoft, in the phase 2. That will expand 3 language evaluation into 10. In order to really serve European Parliament, we need to support the 24 all transcription and translation. Today, actually, Microsoft is the only company that provided a full support of speech translation and transcription for the EU's 24 official languages. No other company actually had the complete coverage yet. So that is really, a high-level summary of the journey of XYZ-code. That is the North Star for our Azure AI efforts. We have the cognitive services that offer the 4 pillar speech, including both recognition and synthesis, computer vision. So this is the perceptive AI pillar, natural language, that included translation, entity recognition, and Q&A, maker, etc. Then we have the business decision. This is the cognitive pillar. So those 4 pillars are expressed through the simple REST API that are available on Azure, that are really serving companies worldwide. We offer the pre-trained deep learning model. We also offer the customization. We understand even with pre-trained model, you need a really adaptation for different domain, different scenario to get the best quality. So that is a consistent behavior, whether it's a speech or vision or language or decision through Microsoft Cognitive Services. So this is all available today. I want to actually cite a few examples I'm personally very proud of. I was a student in Edinburgh, in Scotland. I was doing my PhD there at the University of Edinburgh. Before that, I was a student in China. So when I first arrived in Scotland, I had a little bit of difficulty understand my friends in Scotland. So it was BBC closed captioning that really helped me. So it was a personal coach, almost like I was watching the TV, listening to the BBC radio, and then BBC really helped me remove the language barrier, and I was able to make friends and communicate. It was a great journey. So I was really just thinking, hey, what if we have the capability to transcribe and to translate, or to help everyone on this planet to really communicate better? I'm proud to see today not only PowerPoint, but also Teams offer this live captioning. But most importantly, BBC actually used Azure Cognitive Services, created this custom iconic BBC voice. So they can read any news article using Azure Cognitive Services voice, almost as good as the professional anchor person. That's phenomenal, because BBC voices is one of the most iconic voices on this planet, whether it's in China or in Turkey. BBC voice is really iconic. Today is powered by Azure Cognitive Services. I'm very proud, and that just ability to serve the society that had a deep impact on me personally is just very rewarding. So that is really the story of Cognitive Services. It's a phenomenal journey. I want to actually really close this with a responsible AI angle. Our CEO made this statement. Satya Nadella said, the most productive debate we can have isn't one of good versus evil, but about the values instilled in the people and the institutions creating this technology. So Microsoft takes the responsible AI very seriously. We have published a set of principles from fairness to transparency, and we also shared our practice on how we actually approach responsible AI through our partnership guidelines on the design and the tools available from how we can make the privacy better, to secure the data and interpret machine learning model. Despite of these efforts, I want to share you with two interesting stories. Both of them were published by New York Times. As early as 2018, New York Times actually published this facial recognition bias. They evaluated the three systems from the Chinese company Face++ to Microsoft to IBM. And as you can see, the result had actually a bias towards darker skin versus light skin. You can see the difference here. The delta is actually substantially different. Even though Microsoft had probably the smallest gap, but we had a gap. So we have been working very closely to close that gap. Today, the quality is much better. So this year, there was a Stanford bias study on speech recognition. Once again, it was published in New York Times. And So Stanford researchers, they interviewed both white and black American. They used all the industrial leading speech systems from Apple to Microsoft. Once again, Microsoft Azure Cognitive Services had the lowest error rate and the smallest gap between black and white. But unfortunately, we have a gap that we need to close for African American dialect. The performance was not as good as the white population. So fairness and inclusivity is really important. Microsoft is taking this very seriously. We're working with multiple stakeholders and partners trying to close that gap. It's a journey, whether it's computer vision or speech or language model. We are aware of the challenge. We have to close the gap. So our mission is to empower every person and every organization on the planet to achieve more through AI. And I'm very happy to see what we have done in the COVID-19 fighting. Azure AI Cognitive Services is powered up a CDC conversation chatbot. So help to answer a lot of questions related to COVID-19. In the UK, NHS used our Azure Cognitive Services to validate the user through facial recognition. In Italy, the National Post Office got this voice answering system to help to answer questions for the country to fight COVID-19. And even for students, the College Board used our OCR to help the AP test for students to take an AP exam at home. So it's phenomenal, from BBC to Samsung to CDC. Azure Cognitive Services is helping the society achieve more. It's just a rewarding journey. So I think my time is up. We have 10 minutes left to have Q&A.
Thank you, Tong. Thank you, Dr. XD. That was an amazing talk, very inspirational, very motivational. And I have a number of questions. I'll ask one because there's a number of questions in the chat as well. But I want to quickly put a photograph on the screen really quickly, and I want to ask my question in that context. So I'm uploading this photo. Years ago, I was at a lecture by Professor Hinton, and I took this photograph. And in this photograph, he basically was talking about some of the things you talked about. This was many years ago. And he made this comment where he said, you know, this was when there was a lot of talk about black boxes and these ever-increasing parameter sizes of these massive models. And somebody was asking the question that these models are becoming so inscrutable. They're becoming, I mean, they make very accurate predictions, but it's hard to tell what it is that's driving that decision-making, the rule set, if you will, within the model. It's a black box. We've all heard that said before. So he made an interesting comment where he said, you know, if you want to understand what a model is thinking, just ask it. And essentially he was talking about this notion of learning those relationships within those deep layers, the hidden layers, and then be able to extract them out or pull them out, get a readout from them, to not just say that this is a crow, but to be able to say this is a crow because it has a black beak and because it has black wings. And you can ask a counterfactual question, okay, but then why is this not a cardinal? And then it should be able to say that, well, it's because it doesn't have that. So I found very interesting that in your talk also, you're talking about not just learning correlations, but you're also learning these semantic, these latent representations of the relationships between entities. So would it not be fair to say, Dr. XD, that in addition to actually asking it to, for example, caption an image or to do object detection or instance segmentation, to actually have it give you a natural language text saying it is this because of this, and to be able to understand the reasoning of the model behind the scenes? Your thoughts?
Yeah, that's a great question. How to really interpret the deep learning model is a research challenge. I do not think it's solved the problem, but I believe that the representation, you can actually learn from massive amount of data, but the key is really along the XYZ dimension. You have more information to make sense. So it's more like you know, how we learn as a person. Nobody can understand the language by just listening to the radio or reading the text. But most of the AI solutions today, they're purely just focused on listening to the radio or reading the text and the web scale, right? Like GPT-3 is reading massive amount of text data and the web scale. And it's a powerful tool. And don't get me wrong, you can predict the association, given the text, what is most likely that you are going to actually say. But that's not really about the knowledge or concept understanding. So to ground that with entity is unsolved problem. That's actually a foundational piece in addition to the representation itself. I believe if you have XYZ-code, the representation that's more holistic, you can ground that with knowledge. That's external, that's domain specific. Then we are one step closer to have more usable, more user-friendly AI. The user experience is very different without knowledge. And with knowledge, you can actually really capture the most important salient information, get that right. Without knowledge, it's going to be just, trying to really memorize what you have seen. And most likely, when you make an error, it's a really stupid error because it doesn't have common sense. So it's a research challenge. I hope that 5 years from now, when we actually, reflect back, we'll have a better representation. We'll have better grounding with external knowledge. That's domain specific. Combined with those two, a lot of those downstream tasks will be far more effective, far more user-friendly, and far more intelligent.
Thank you, Dr. XD. And just a quick comment and a question. I know from there's lots of questions in the chat, but somebody actually, one of our audience used your app and they were very happy with how accurate the app was, not just in detecting the objects in focus, but also the context environment elements around it. They have asked this question, Dr. XD, you talked about the parameter space and how it went from 1.5 to 15 to 150. I mean, that's logarithmic scale. And so the question is, Dr. XD, that do you see hardware constraint? I know you talked about parallelization and distributed training, but at some point, do you see a bottleneck with these models getting so big that the hardware compute isn't keeping up with those advances?
Absolutely. It's just today, I would say, silicon and the software are really, really advancing on both dimensions. NVIDIA is doing a phenomenal job. The latest chip from NVIDIA A100 is phenomenal. And the amount of data we have accumulated is also phenomenal. Combined with deep learning, there will be more breakthroughs to come. So given that challenge, how to influence this in a cost-effective way remains a pragmatic concern for all of us, right? So Microsoft actually is pushing very hard because we have Azure cloud and the GPU services available. So it's really a massive supercomputer in the cloud. We can take advantage of that. But for most of the researchers in practice, influence is also important. You want, do this efficiently. Azure Cognitive Services recently published a paper we call the fast former. It's really a fast transformer solution that can really increase the efficiency by 10 to 20x in comparison to the standard way of doing transformer inferencing. But that's still not enough, as you said. This, the growth of the size of the model is just, phenomenal. It's exponential. So how we can really have an efficient way to inference remains a challenge. We are taking that very seriously because we are serving millions and millions of, I wouldn't say the exact number, probably billions of API calls. Without having an efficient mechanism, there's no way we can really, deliver the service in a cost-effective fashion. So we have invested tremendously in the Azure Cognitive Services that's not only secure, reliable, but also cost-effective and maintain state-of-the-art performance. So that's a combination of many, many things. It's a unique challenge that requires deep engineering, research combination, and hardware is part of that equation.
Thank you, Dr. Huang. So one last question in the interest of time. There is a question here from one of our data scientists in the audience that is there a human in the middle for the European Parliament application, and how does the automatic translator handle mistakes?
I don't think that is our decision. European Parliament basically asked the international community to participate in the bidding. They want to measure the quality of transcription and translation, regardless of the language. And the phase 2 is actually 10. Phase 3 will be all 24. And we have the capability to really recognize 24 and transcribe and translate. And so they picked 3, English, German, French, in the first stage. If they want to have a human in the loop, they can do that. But we are only responsible to provide the platform capability of AI services. How they're going to use that is up to them. But it's just amazing. The first stage of live translation and transcription is very impressive. So I'm sure they will have human in the loop or not human in the loop. It depends on the scenario. The goal is to bring citizens closer in the European Union, so you can really understand the debate and the speech of the member of the parliament. That official transcription and translation will be important to be accurate, not to mislead the citizen, right? So how they're going to do that, I think it's up to the European Union Parliament.
Thank you, Dr. Huang. And what I found very impressive in that demo which you did for us was that when I was looking at how the words were not just getting added to the end of what had been translated, but how words earlier in the translation were being changed, because as the context was better understood downstream, it made upstream changes to ensure that the context remained intact and whole. I mean, that was fascinating.
Right. Precisely, yes.
Yes, thank you. So, Dr. Huang, thank you so much, Dr. XD, for sharing your time and your wisdom and your insight. And as I mentioned at the beginning of the talk, when this pandemic thing is over, we'd love to have you join us at the home of the Synthetic Intelligence Forum, which is Toronto, and have you come out and meet our community in person and give talks of this nature to technical and practitioner audiences. So thank you very much. And look forward to seeing you again soon.
My pleasure. Thank you so much.
Okay. Bye for now.
Bye.